So I'm going to give some answers to these questions. Naturally, the answers to these questions will be verbal, but when you're listening to the video, you can write down what I say if you want to check your answers. First question says, briefly define metamorphism. Metamorphism means to change form, so the rock actually changes form. It does so by a reduction in volume, which equals an increase in density of the rock, also a textural change in texture, and also recrystallization of brand new minerals. List the 3 controlling factors in metamorphism. You need to have heat, you need to have pressure, and you need to have hot chemical fluids, for example, extremely hot water. Why is heat such an important agent of metamorphism? Heat basically helps with making the chemical fluid hot. So basically it's the source of making water extremely hot. And the hotter the water is, the better it is at dissolving away minerals that exist in the parent rock and helping with the reformation of minerals in the new metamorphic rock. What do chemically active fluids do? Well, the thing that I've been really trying to stress to students is that in order to get a metamorphic rock, you do not have melting. There's no such thing as molten, magma, lava, any of that involved. So when people talk about recrystallization of new minerals, they often make the mistake of saying, oh, the rock melts and then you get recrystallization of new minerals. That's not true. So what you actually get is are chemically active fluids like hot water that basically helps with dissolving away the minerals that existed in the parent rock. And then you got to remember that minerals are made of compounds and compounds are made of elements. So those elements can redistribute themselves, make new compounds, thereby making new minerals in the new metamorphic rock. The parent rock certainly affects the metamorphic process because whatever minerals are in that parent rock, that's all you have to work with. So those minerals are made of compounds, those compounds are made of elements. So whatever elements are found in the parent rock, they're the only elements that you can rely upon for making new minerals that will be in the new metamorphic rock. What is meant by the term foliation? Well, foliation is just simply a type of texture that metamorphic rocks can have. We like to think of foliated being like banding. The minerals are essentially just in a line with each other. Listen briefly distinguish the 2 types of stress or pressure that could be involved in the process of metamorphism. I'm just going to really talk about one type of stress, and that's basically stress due to being buried. So stress due to burial. So if you have a rock that's buried deep underneath the Himalayan mountains, then naturally it's subjected to confining pressure. So just pressure due to burial. Distinguish between contact metamorphism and regional metamorphism. This is a really important question. Contact metamorphism means that rocks have to come in contact with something that's incredibly hot. So typically it involves lava or magma. So already in this course we've talked about lava extrusions and magma intrusions. The other thing that could apply here is a meteorite impact. So the meteor strikes the earth with so much force and so much pressure, and it creates so much heat due to friction that it metamorphoses the rocks that it touches. So for contact metamorphism, just think about lava extrusions, think about magma intrusions, and think about meteorite impacts. For regional metamorphism, this is a type of metamorphism that takes place on a larger scale. You get a larger volume of metamorphic rocks, and it typically takes place deep inside of mountain systems or down subduction zones, which both relate to mountain building. Which agents of metamorphism dominates in relation to each type of metamorphism? Well, the first thing I'd like to say here is that for contact metamorphism, you need all 3 agents. You need heat, pressure, and hot chemical fluids. Same with regional metamorphism. You need heat, you need pressure, and you need hot chemical fluids. The one that dominates for contact, though, I would have to say is heat, and the one that dominates for regional, I would have to say is pressure. So think about really, really far down at the base of a mountain system, like 40 to 50 kilometers down underneath the Himalayan mountains. The pressure is going to be pretty high, whereas if you're actually touching a hot magma, well, the heat is going to be really high. So the question said which one dominates, so they are my selections. Number 10 is a really, really important question, hence the reason why the word important is here. Often shows up on a public exam. So if you were to take a sedimentary rock called shale. So shale is a sedimentary rock. It's essentially mud particles that got lithified to make the rock shale. If you subject shale to metamorphism, so to a lot of heat and pressure and hot chemical fluids, you get a rock that's called slate. Just remember that slate is low-grade metamorphic rock and it's foliated. If you metamorphose slate even further, you get a metamorphic rock called phyllite. Phyllite is medium grade, also foliated. If you metamorphose phyllite even further, you get a metamorphic rock that's called schist. Schist is a high-grade metamorphic rock and is also foliated. If you metamorphose schist even further, you get a metamorphic rock that's called gneiss. Gneiss is extremely high-grade. It's one of the highest-grade metamorphic rocks that you could possibly get and has really, really, really strong foliation. The next question, number 11, involves a textbook. You don't have a textbook at this time, but essentially all that it is exactly what I just explained for number 10. However, it's in a plate tectonic setting. So if you were in class, I drew a picture of a convergent plate boundary. In fact, the one I drew on the board was an ocean-continent collision, where an ocean collided with a continent, and every continent has a continental shelf, which is predominantly sedimentary rocks. And so what I showed you in that shelf is as the shelf gets pushed together due to the compression and the convergence, if you had shale that got subjected to high heat, pressure, and hot chemical fluids, you could go from shale to slate, slate to phyllite, phyllite to schist, and schist to gneiss, which is what I explained in question number 10. You really do need to see that diagram. So if you missed that class that day, you need to find that diagram from a classmate, or you need to look in your textbook and to try to find, or on the internet, and to try to find a diagram of an ocean-continent collision or a continent-continent collision, both of which are convergent plate boundaries. List 2 metamorphic rocks that have a foliated texture and 2 metamorphic rocks that have a non-foliated texture. Well, for non-foliated, we only did 2. We done marble and we done quartzite. For foliated, we done 4. They only want 2, but I'm going to list all 4. Slate, phyllite, schist, and gneiss. What is meant by a buried lava flow? Well, for a buried lava flow, say if you had a layer of sandstone, and then you had magma that shot up through the ground, and then the magma poured out of the ground in a lava flow. So here's our lava flow like this, and then let's say that it all got buried again, and it got buried again by sandstone. It would have X's all along the bottom, and those X's would represent contact metamorphism. But the key to a lava extrusion is making sure that the X's are on the bottom only. There's no X's on the top because there was nothing on top. This layer of sandstone right there, it wasn't there. It was the atmosphere. There were birds flying in the sky. There was no way that that could get metamorphosed because that layer came after. I know I just called it a lava extrusion, but a lava extrusion is a lava flow. And in this particular case, the lava flow got buried, and that's the reason why sometimes the term buried lava flow is actually used. I'm going to scoot down to number 15 because number 15 is the opposite of a lava extrusion. It's a magma intrusion. So magma stays down inside the ground and it intrudes inside of rocks. So let's just say, for example, if this was a big section of rock, and I don't know, let's pretend that it's sandstone. So this is all sandstone, little dots representing sandstone. And let's just say a big hot magma chamber pushed its way all the way up to the ground here. So this is like 2,500 degrees Celsius, molten magma, never ever gets to the surface, and the magma chamber stops right there. That is so hot that what it does is it bakes or it contact metamorphoses everything that it touches, okay? And so for a magma intrusion, it's important that you understand that the X's can be all around it, top, bottom, sides, everywhere. Whereas with the lava extrusion in number 13, the X's are on the bottom only. For number 14, it says, why are metamorphic rocks found in the cores of Earth's major mountain chains? Well, if you're talking about Earth's major mountain chains, you're talking about deep at the bottom of mountains. The pressure is incredibly high. The heat is incredibly high, and hot chemical fluids are down there. So the heat actually makes the hot water, or the water, really, really hot. So they are the 3 agents that you need for metamorphism, so that's why that location is really, 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 really good. So moving on to number 16, and you may have to use Google, and you could probably Google yourself a picture of granite and a picture of gneiss. So granite is an igneous rock that cooled slowly from a magma, and gneiss naturally is a metamorphic rock, an extremely high-grade foliated metamorphic rock. But from class, you should know that gneiss came from granite. So if granite gets exposed to heat, pressure, and hot chemical fluids, you can actually get gneiss. When you Google both images of both rocks, what you'll notice is that they're very similar in color. And what that actually means is that the same minerals that you have in granite, you also have in gneiss, even though the minerals that are in gneiss have been recrystallized for the second time. Number 17, which pair shows the relationship between the metamorphic rock and the parent? This one's easy, it's B. Limestone metamorphoses into marble. Which is a metamorphic rock texture? There you go, foliated. We only done two types of textures, foliated and non-foliated, so that one's pretty simple. Moving ahead, which has the least impact on metamorphism? Well, for metamorphism, you got to have heat, so there's temperature. You got to have pressure, and you got to have hot chemical fluids. Faulting, we never talked about, so that would be the answer to that particular question. Which occurs at the boundary of an igneous intrusion and existing rock? Well, in this particular question, we said intrusion, so we're talking about a magma intrusion. Magma, when it touches existing rock, is going to bake it, and so contact metamorphism is the only thing here that actually means baking. Moving on to the next question. This rock is formed when a lithified sand dune. So for this particular question, sand, loose sand, gets lithified, which means turned into stone. So you have a rock that's called sandstone. Now it becomes really simple, because if you metamorphose sandstone, what do you get? You get a rock called quartzite, which is a low-grade, non-foliated metamorphic rock. Moving on to 22. Which metamorphic rock forms under the lowest temperature and pressure conditions? Well, gneiss is an extremely high-grade rock. Phyllite is a medium grade metamorphic rock, and schist is a high-grade rock. So that means that slate, which just happens to be on a page on its own here, slate forms from low temperature and pressure conditions and hot chemical fluids. So slate is the only one here that would qualify as being low grade. Which type of metamorphism affects the largest volume? Well, there's only two types of metamorphism, remember, contact and regional. Just the word regional. Regional means a big, large region, a large area. So you're going to get the largest volume of crust. And that's why regional metamorphism typically relates to mountain building. This particular diagram down here, all they're trying to show you in this diagram, that the minerals are aligning themselves this way. So you can look at these big minerals labeled X. They're aligning themselves from left to right, which would mean that the pressure direction is perpendicular to it. So the pressure would have to be coming this way in order for the minerals to line up that way. And so if we look down here, the answer would be C. And so hopefully those explanations help you if you're at home with this worksheet in front of you and you want to just, listen to me give the answers, or if you want to check your answers to see if you have them right.